Today's question is minimum cost path with age reversals. Okay, so you are given a directed weighted graph. You can see here with n nodes level from 0 to n minus 1 and an array ages where ages of I is equal to ui, vi, wi, where wi is the weight of that particular age, represent a directed age from u to v with cost w. Now each node u has a switch that can be used at most once. Okay, when you arrived at u and have not yet used its switch, you may activate it on one of its incoming edge v to u and reverse the edges u to v and immediately traverse it. So if we want, suppose we can calculate like this: age is from 3 to 1. We can calculate create a age from 1 to 3, and as given, its weight will be simply twice the weight of the reversal age, so it will be 2. And then we have to return the minimum total cost to travel from node 0 to node n minus 1. And if it is not possible to reach this n minus 1 node, then we have to return minus 1. Okay, so what logic we'll be using here? So here we have been given directed graphs. We will create it undirected graph. We will create the reverse edges also and add that in the adjacent list and give it weight just twice of this. So let's do that. So simply we can create adjacent list for I in range n. Then we can simply go for u comma v comma w. W is weight in ages. Adjacent list of u dot append. We will append two things. What are first the node and second thing is the this weight. And now when we are creating this reverse age like from 1 to 3, how we will create that? Adjacent list of v dot append. What we will append? The node itself. And what will be the weight? It will be twice as given in the question, this 2 into weight. Okay, so now we have created the edges. Now simply we will use Dijkstra's algorithm to traverse the path. For that we need to import heap. Now simply create a list like pq is equal to this, and then what else? We can first create a distance array. We will set each value to float infinity initially. Float infinity for I in range. Float infinity for I in range n. Infinity for I, is this correct? Yeah, float infinity for I in range n. Yeah. And now we have to calculate the path from 0 to n minus 1. So the distance from 0 node to 0 node will be 0. So we will set it as distance of 0 node is equal to 0. Okay, now we will just append it in our heap. So heap q dot heap push, where we have to push pq, and here we will append. First will be the distance and second will be the node. And now simply run the loop while pq distance comma node is equal to heap q dot heap pop. Whichever element is at the top means it has the least distance, so we will pop that particular element, heap q dot heap pop. Now we will traverse it in its neighbor. So for neighbor comma weight in adjacent list of C. What the adjacent list contains? Neighbor and its particular weight of the edges. So adjacent list of that particular node. So if the distance plus weight is less than distance at that particular neighbor, so we will simply update its distance. So distance at that particular neighbor is equal to distance plus weight, and we will simply push it in the heap queue. So heap queue dot heap push, to push pq, and first we will be pushing the distance. So distance is nothing but distance of neighbor, and what is the node? Node is nothing but the neighbor itself. And yeah, so that's how this will be calculated. And suppose if distance, what we have to return, n minus 1, distance at minus 1 is not equal to float infinity, means we have got a shortest distance, float infinity, so we can simply return distance at n minus 1. Else suppose it is till now it's infinity only, so we can simply return minus 1, because it is not possible to reach there. Now we try to run and see. Okay, so test cases have been passed. Let's try to submit this. Yeah, so our code has passed successfully. Thank you for watching.